So this week's going to be about flow control. There again, for this week, you'll read the chapter material. You can use this diagrams.net. We're going to do that just a little bit to understand the concept of flowcharts. You have assignment 2 this week, similar type instructions that you had last week. So you guys will work through that. Big ones on this particular assignment are making sure that you use 2 different comparison operators. So if you use equals, equals, and we'll talk about all these here in a little bit, greater than, less than, greater than, or equal to, less than, or equal to, you need to use more, at least 2 of those. And different ones. Don't use all equal type stuff. You'll need a Boolean operator. You'll need a if statement, 2 elifs, and 1 else all in one chain. And we'll talk about those here in just a little bit as to what they are. While statement that has a break and a continue. People tend to forget the continue portion of that. You'll need one that has a for loop and uses the range method. And then you'll need to use the random module and a random init to generate a random number somewhere in your script. That'll all make sense after we talk about it, but at least you know what to listen for when we go through flow control. As always, there's some older videos down here at the bottom you can always watch if you don't quite get it. So flow control. When you're building a program, there's different statements that are in there that are used to design a flow control. A lot of people have seen flow charts, and that's the easiest way to design programs. So for this example, you start at the top. You're going to go to the question of, is it raining? And then depending on if it's raining, you go to a yes and you go to a no. And they have 2 different logic groups that go on that. So no, you go outside into the ground. Very simple. In this case, if it is raining, then we're going to go ahead and check, see if we have an umbrella. If yes, go outside. If no, do this. Then kind of loop all the way through. You can obviously get into loops, but they all find their way back to the original part of go outside and in the program. So very simple. You guys will be able to use flowcharts. When you start working through this homework assignment, I encourage you to go out to that diagrams.net link, kind of build a rough flowchart as you start working through ifs and elifs. It's very easy as we start talking about those to get very nested in those, and you start having a whole lot of issues. So try not to nest into too deep of if elif chains. Otherwise, your program is going to be really messy. And if you make an error, it's really hard to figure out where you made the error. All right. So in a basic sense of yes or no, in Python, that's going to be the equivalent of true or false. So when we deal with Boolean values, this will be an integer, a floating point, or a string. You have unlimited number of possible values. When it comes to Boolean, there's only 2 types. You have true or you have false. Note, in Python, you have to make sure it starts with a capital T and a capital F. If you do true and false as lowercase, that means something completely different. It's a variable name at that point. So capitalization matters when you're starting to work with those. So in this example, you can say spam equals true, which means at any point we use spam, we're going to return a true value at some point. So we can say, does spam equal 2 + 2 is 4, that kind of stuff. Okay. To get Boolean values, you typically have some comparison operator. It's the output of some comparison statement. And in this case, we're going to work with these relational operators. So all of these are going to compare 2 different values and then evaluate those down to a single Boolean value and return it. So we have a double equal sign, which is equal to. We have the exclamation point equal sign, which is not equal to. Less than, greater than, less than or equal to, or greater than or equal to. So you can use these to compare numbers. You can use them to compare floating points, whatever you may want to do with that value. You could also check with the equal equals if it is something on a string. So if you have somebody type something in, so if we look back at last week's assignment, we could check if somebody typed something in. We can do if it's equal to, say, Jason, when we added in a name. If it's equal to Jason, we print something out. If it's not equal to Jason, we print something different out. That's why we're doing those comparisons. That's on a string. Most commonly, these are going to be used with numbers of some sort, particularly in the case of all the other ones down below. All right, so they'll show you some examples of how to use these. Like I mentioned, you could check if hello is equal to hello. Note that when you have something like hello here, which has a lowercase h, versus something that has a capital H, it's going to return false. Again, capitalization matters in Python. You can check to the not equal, equals, equals, all the way through. Anybody have any questions on operators? Okay, this is the part that they put in gray here because a lot of people get tripped up on it. The difference between a double equal sign and a single equal sign. A double equal sign is saying, is it equal to, and is it checking to see if there's two values are equal to another. The single equal sign just puts an assignment to whatever variable, right? We learned that last week. This is often confused because when people do if something equals Jason, well, I only used one equal sign, so it just assigned that variable Jason. I didn't do an actual check on it. The code will sometimes continue to execute, but it's not going to work like you intended it to work. So anytime you're doing a comparison, it's a double equal sign. Okay. The other operators we're going to talk about, we'll talk about Boolean operators, not going to be confused with Boolean values, right? So Boolean values are going to be true or false. Boolean operators are and, or not. And these basically boil down to truth tables, which you guys have probably seen this in a general logic class or something along the way, where if it's true and it's true, it equals true. If it's true and false, it's false. False and true is false. False and false is false. So you're checking to see if two values are working. So you can say, for example, let's fire up idle here. I can say 2 plus 2, and I'm going to get back true. So 2 plus 2 equals 4. If I just do 2 plus 2 equals 4, it's not going to work right, because I'm not comparing to see if 2 plus 2, it evaluates down. Then I'm checking to see if that equals 4. Again, this is where a lot of people mess up because of common math and things that people are used to. But we can check to see if something's true and true, then it's true. If it's true and false or false and false, then it's not going to work. All right, you have this as your and truth table. Your or truth table is just the opposite. So if it's true or true, then it's true. If it's true or false, it's true. If it's false or true, it's true. And if it's false or false, it's false. Does that trip anybody up or have any questions on that? Sometimes a little tricky, but if you think through it pragmatically, it's pretty clear. Okay. For the not operator, it's just the opposite. So if you say if something is not true, then it evaluates to false. If it's not false, it equals true. Again, you're going to have to use some of those on your homework assignment when you go through there. So you can check to say, say you gather their name, right? And you gather their age. You can check to see if they have a name of Jason and if they are greater than 18. And if that evaluates, then that's true and true. Therefore, you're going to run the code under that. If any one of those is off, then it's going to kick it down to your else statement, which we'll talk about if else's here in a little bit. Okay, when we're working with flow controls, everything is basically a condition, which is what we talked about before. So conditions are just a specific name in the context of flow control. Conditions always evaluate down to a Boolean true in case of true or false, and that flow statement decides on what it's going to do based on whether it's true or false. So when we work with Python, we work in blocks of code, and all this code grouped together is considered a block. The blocks always begin with an indentation increase. Blocks can contain other blocks, and blocks end when the indentation decreases to 0 or the containing blocks indication. So what does that mean? If we look at this down here, we say that name equals Mary, that password equals swordfish, and then we check to see if name equals Mary. Then we print hello Mary, and if her password is equal to swordfish, then we print accept access granted, else we print wrong password. Notice how this if starts over here on the left, Then we indent one tab over for the text below it. Once we get into another elif or an inside if, it needs to be tabbed over once more. So tabbing and grouping and blocking is important. If your code's not working right, you probably don't have indentation incorrectly. Anybody have any questions on blocks and indentation? It's a real quiet group, so you're either super smart or you have no clue what's going on. Which side are you guys leaning on? Super smart, right? We'll find out on Sunday. All right. So that brings us to flow control statements. The first one we're going to work with is if statements. So you use the if keyword. It needs to have some condition that's going to evaluate down to true or false. You'll use a colon after that, whatever that condition is, and then you'll start the next line on an indent block of code. So if we look at this example here, I'll zoom in a little bit. If name equals Mary or Alice in this case, notice that we have the next spot indented to print, and then we go through. Yeah.
Why do you put 2 equal signs?
Because 2 equal signs is the comparison. So we're checking to see if name is equal to Alice. If you use a single equal sign, it assigns name to Alice. Yep. Good question. Great question, because this is where people start to get tripped up on those 2 equal signs. So notice on this if statement, we have if is our keyword, name equals Alice is our condition, and then we have a colon at the end. The next line is then indented one over, and this is what we're going to do if it's true. If it's false, the program just keeps moving on. It will not execute this print hi Alice. So if we look at this in a very basic flow chart, we start, we check our condition. If it's true, we print. If it's false, we end the program. Very, very simple.
So a flow chart pretty much just shows you what can happen if it's true or false.
Exactly. A flow chart is just a visual representation of what your program is.
Okay.
And it's beneficial for some people to think through it, especially when you get into much larger projects. Then a flow chart is going to be way more helpful. Does it mean you have to do it every single time? No, but it will certainly help you with your code, especially if you're nesting a bunch. You can draw this up using diagrams.net. You can draw it on a piece of paper, whatever you got to do. But sometimes it's nice to follow and flow through this chart. All right. So if that condition is true, then we're going to print hi Alice. If it's false, we do nothing at this point. So now we're going to use an else statement. And an else statement is used after the if was defined. It's going to have the else keyword, a colon, and then what the next line below it is whatever code we want to execute. So if we take that same program, zoom back in here a little bit. If name is equal to Alice, then we're going to print hi Alice. Then we have else. Notice that there's no condition on an else statement. It's just else. Then we print hello stranger. So if we look at this flow chart, it changes to where now we say, okay, is name equal to Alice? True, we print, go to the end. If it's false, it's something else, then we print hello stranger and then end. So if we combine this little program together into a project, we can say print what is your name? Taking a little bit from last week. Then we're going to set that. So name equals input. Again, we can set an input prompt to make it look a little cleaner when we gather that from the user. And now we can use that same code that they have here. So if name equals Jason, print hello Jason. Okay, that's all we have. And then we're just going to put a print down here at the bottom so you can see the difference that says, thank you for using my program. Okay, if I run this code, of course, I have a typo in there, but it asks, what is my name? If I put in Sally, it just says, thank you for using my program. Notice that it did not execute this code because when it evaluated what I typed in and compared it to JSON, it did not match. It went to false, and therefore it just says, thank you for using the program, and the program ends. If I throw in a condition now that says else, print hello stranger, let's go up here and fix my top part. Now, if we run this code, if I type in JSON, I get the hello JSON, thank you for using my program. If I rerun this and type in Sally, now I get hello stranger, thank you for using the program. So if it equates here, we get this line. If it's something else, we print this. Anybody have any questions over these if statements? Okay. Say we want to find out whether or not your name is Jason, we're going to do something, but if your name is Sally, we want to do something different. So we're going to use an elif statement. This allows us to check things multiple ways before we do the catch-all else statement, right? So in this case, it's going to look very similar to an if, where the elif is the keyword, we have a condition, we have a colon, and the next line of code. So if we go back and modify ours, it always goes if first, then an elif, and now we're going to say elif name equals Sally. Then we're going to print okay. So if it's Jason, we're going to print hello Jason. If we say names is going to be Sally. If it's Sally, then we say Sally, hi, you're better than Jason. Otherwise, if you're some other random name, we're going to say hello stranger. So let's run through our checks. We do Jason, that works as we intended. We run it again and say Sally. We get Sally's output.
Did you essentially put elif right there?
I did, yeah. Yeah, so now we're learning about elifs, right? So the idea is that I can now check for multiple names and I can have different print outputs based on different names.
Okay.
You can use as many elifs as you want. So say we come down here and I want to check for not only Sally, but I want to check for Sam. Then I can do something entirely different than a print. I may ask for more information. So for example, print what is your password? And I can do something like password equals input. Again, give myself a decent prompt. And now I can do something like print Sam, your password is okay. So if we look at this little chunk of code, we're going to do a simple print for Jason. We may add something else in there. You may say something like print. Let's do this way. Can anybody tell me what this print statement's going to do? It's going to show what 10 times?
But you said which
This one here. So does anybody remember what this string, this asterisk, and then a number does? Replication, right? Yep. So this is string replication. It's going to replicate this hashtag 10 times. So why would I use this? Well, let's take a look at the program. We can do something like JSON. It does 10 of those hashtags across. Now I could build a menu system. I could do whatever I wanted, or you could use asterisks or some other key. It doesn't matter. All right. If I run Sally, we just say Sally is better than Jason. The program ends. If we check for Sam, now we go on and execute completely different code. So now we want to check a password. And we say, Sam, your password is whatever it is. Now we could store it, we could check it, we could do all sorts of stuff with it, but anything that's inside this block of code is relevant to the SAM. So this is like your homework where you need to have at least one if statement. You need to have at least two elifs. You can have as many as you want. And you need one else statement at the bottom. You need to make sure that your else statement is actually going to be used at some point. So you want to make sure that your elifs are there, and then you put an else statement that never gets used. Well, why would that be? Well, say I'm checking age, and the first if I check is to see if I'm over 18. The second elif is going to check of whether I'm between 18 and say 30. And then my third elif is going to check if I'm greater than 30. If I type in the number anything, am I ever going to hit else? Let's take a look at it. So if I say print, what is your age? Again, at this point, we're going to assume that they're actually going to give us a number. So we're going to say age equals input. Remember that when you get input, it is a what? What data type? String, right? So if we give them an age, we got to convert that over to an integer in order to do any kind of checks against it. So we can say if age, and again, we need to do int and put that in the int function so we get back an actual integer so we can do math on it. So if int is greater than 18, print you are an adult. We can check elif int of age is greater than 30, or in this case, we're going to say, greater than 30. And here's where we're using an and statement. This is the Boolean comparison operator. So both of these conditions have to be true. We need to have the full condition here. So you can't say if age is greater than 30 and less than 30. That does not work because there's nothing to compare in front of it. So we need to have int age. Therefore, this is a condition, right? Is int age greater than 30 or is integer of age less than 30? In this case, we're going to set this a little higher. We're going to set this to 65 and say print, you are a working adult. And we can have an elif is int age greater than 65. Print you are retired. And we can have an else print that didn't seem like a valid answer. Okay. So there's a couple of things we can do with this piece of code. Notice how I had to type int age every single time I did this, right? Instead of doing this every single time, I can just convert it ahead of time and say age equals int age. Now, all I have to do is just have age here. I don't have to retype int every single time because we've already converted it once over to an integer, and therefore I don't have to do this check every single time. So why is that relevant? The cleaner your code, the better your code. But because I converted this over to an integer, from here on out in the program, it's going to be an integer. Remember that Python works from the top all the way down, line by line. So if I look at this code, I ask for an age, I convert that age over to an integer. And then we can say, if that age is greater than 18, you're an adult. If age is greater than 30, but age is also less than 65, you're a working adult. If age is greater than 65, you're retired. And on else, it says it doesn't seem like a valid answer. Where would this else get triggered? Less than 18, right? So we could change our output to say you're underage or something more relevant. So if we run this, and I'll hold this over here to the side, we can say, what's your name? I'm going to say Jason. Notice that this part of our code is done. So this is basically a block up here. Now we're going to start into our second part of the project. So up here, it would be good for us to put a comment and say, get the user's name. And we could identify this next section as a comment and say, get the user's age. And it's good for you to try to keep this kind of stuff together and make comments all the way in. We could say end of program. And we could put something at the top here and say start of program. And actually, this needs to go inside here, right? It's relevant to getting the name. So we could do print. Not type today. Okay. Obviously, before this, you need to have your initial comments. So INF 360. There we go. Okay. Again, you can paste in the actual requirements and go through there. I'm just showing you examples. This wouldn't necessarily be assignment 2. So we start with our program. We're then going to ask for the age, deal with the age, and we're going to do comparison operators. So in this case, notice I'm only using equal to as my comparison operator. If I submitted this homework assignment, it wouldn't count because I only used one comparison inside of here. I need to have at least 2. So now I'm going to deal with age, and a number is the greatest way to get other comparisons. So now I have an age, and I'm going to be checking for greater than, or less than, greater than, etc. Now, if we take a look at this age part, let's go ahead and run that again from the start. If I check this and I say I'm Jason and I say I'm 12, it says I'm underage. So we got that to work. It checked all of these and immediately found that else is going to be here. Now, if we run this again, what happens if I say I'm 18? It says I'm underage, right? Oops. I'm underage. So what do I need to do? I need to change this to greater than or equal to in order to signify that I'm going to be above. So there we go. Jason, 18. Now I'm an adult. What happens if I say I'm 30? Right. So if I want to check these inside of here, but include these numbers, I need to make sure I throw those equal signs in there as well. The way. Yes. Yes. The question there was, do you put the equal sign after the greater than or equal to? Yes. And again, those are very similar. If you just come up here and look at your comparison table at the top, you can see which ones are valid for Python. Great question. Okay. So you'll want to work through your project, and this is exactly how you'd work on your homework assignment. You run it, you test it, make sure your conditions are meeting exactly where you would expect them to. Double check your projects, because as your projects grow, in this case, these are homework assignments, but once you get to your midterm project, I will intentionally try to break your programs. So if you ask me for a name and I type in a number, you should tell me that is a number, not a name. You'll learn how to do that. If I check here, I'm going to check all your conditions. If you say greater than 18, but what happens if I find that one in between, then you would receive points off for that. You should have conditions to meet everything in your project and do validation. So when I talk about validating your project or sanitizing it, this is what I'm talking about. Going through, checking everything to make sure you get the desired outcome you should be getting. All right. So if we look again back at the homework assignment, you need to use two different comparison operators, which we did. We used equal to, and we also use greater than, less than. We use greater than and equal to, and less than and equal to. We need to use a Boolean operator, at least one of them, which is and or not. We did that here in this section where we did two checks. We checked to make sure that it was greater than, or I'm sorry, yeah, greater than 30 and less than 65. It needed to meet that condition. So and is our Boolean. Notice when you use these, it changes the color of these inside the idle to signify that you are using a Boolean operator at that point. All right. We also need an if statement that has to contain at least two elifs and one else. Now we're going to talk about while loops. So in a while loop, it works just like an if statement in that you'll have a while keyword, you'll have some condition, you'll have a colon, and then you're going to have a block of code. So a while loop is going to run as long as that condition equates to true. So whatever you have in there for your condition, as long as it's true, it's going to continue to run. So let's look at a while loop in here after we do the H thing. All right. So the simplest while loop you can do is while true. That means it's pretty much going to run forever until I end it at that point. It'll just stay in that loop and run forever. So if I say print my while loop, and then I run this program, oops. We put in JSON, we put in 15. This project will never end. At this point, it's just going to say my while loop and it'll go on continuously. You will end up doing this. That's the reason I'm purposely doing this. So if you hit Control C, it will interrupt that while loop and dump you out of that while loop. So because the only thing that's in here is print my while loop, it's just going to do it repeatedly until you interrupt the project. Again, Control C is how you get out of that. Okay. So other things we may do in this while loop is we can use it for sanitization. So we can say print, in this case, I'm going to go back and clean up my name. Actually, we don't have checks on that yet. So you could do a couple different while loops. Again, you can do a condition. So while count equals, or if count is greater than 5, then we can say print count is currently sorry, let me get this in here. Okay, so if we look at this code, I'm setting a variable called count, and I'm setting it equal to 0. Then I'm going to run my while loop. So while count is greater than 5, then we're going to print the count is currently this. I have to use the string function to convert this integer over to a string so I can print it. And then I'm going to take count and I'm going to say count equals count plus 1. And that's just going to add 1 back to the number count. And then it's going to continue this loop over until count is greater than 5. Now, this doesn't make sense because this will never run, right? Count is equal to 0. So let's switch this around to less than 5, and then we'll run it. For now, I'm going to comment out this top part. So if I go to edit, and I'm sorry, format, and go to comment out, it's going to comment it all out for me all at once. That way this part of the code doesn't run. If I want to turn it back on, I just highlight all of this, format, uncomment, and now that code will continue to run. Very helpful. If you already know a good chunk of your code is working, you can comment it out, focus on the section that's not working. So if we run this code, notice that it says, welcome to my program. We get the first count here where count is equal to 0. We add 1, then it loops back over because the condition's met until count is at 6, at which point it kicks out of it and says end of the program. So now I do it 0, 1, 2, 3, 4. There's 1, 2, 3, 4, 5 lines, but we went through the loop 4 times. Or 5 times, actually. Does everybody understand how that while loop works? Again, if you do a straight while true, it's going to loop over indefinitely. So it's part of a while loop. We have the ability to set a few things. So this is always a good example and things I like to have people check here. Because this condition is going to be constantly met until you kick out of it. So if I comment this out, because we're going to come back to it, and we use the one, the example in the program here, and we say name equals empty space for now. And we say while name does not equal your name, print, please type your name. And then we get our input, name equals input, print. Thank you. We got to get this back out of here. Let's leave that part off. Okay. We have to define name first, and then we set it to an empty equal sign, because if we don't define it before we start the while loop, it's going to say name doesn't exist. So for example, if I comment this out and then try to run this code, it's going to error name not defined. So name is not defined. Before you do a while loop, you have to define it. You can't define it inside the while loop as a condition. So for now, we're just going to set it to empty. And it says, please type your name. We type our name. It just keeps looping us over and over and over. The reason it doesn't work is because we set our condition to equal your name, which means it has to specifically match this string. So we would have to type in your name, then the program would end. It's simple but effective in understanding that this condition has to be met in order for the program to end. Okay. Along with the while loop, we have the ability to use break statements. So a break statement would allow us to come through here and break out of our while loop. So if some condition is met, say we do an if statement and say, if count is greater than 3, then we're going to do a break. It just kicks us right out of the while loop. A continue statement is going to execute some code, then continue the loop back over from the start. So to get out of an infinite while loop, we would have to use a break statement at one point. So the difference between that first code where we say, while your name is this, now we're going to use a while true statement. While true, we say print, and now we're going to do a check. If name equals your name, then we're going to break out of our program. That's the difference between doing the condition up here in the while true and doing the check down here. Now, the reason we would want to do this in a while true is it's going to keep this infinite loop until you actually hit the condition you want and break out of it. When you guys start sanitizing inputs to make sure that they're typing in names and numbers and stuff like that, the easiest way to sanitize inputs, put it inside of a while true loop, check for your conditions, sanitize it, then break out of it when it's clean. Then you can continue on with your project. And we'll teach you guys how to do some checks here. That's coming up in the next couple of weeks. Anybody have any questions on breaks? I could also do a check and say elif name equals Jason. We can do print. Nice try, Jason, but that is not what I am looking for. And whoops. Then I can do a continue here, which will just start that loop back over. Now, if I run this, so now it's asking for a name. If I do something else, it's going to just loop me back over and say, what's your name? If I say Jason, it's going to give me some printed output, but just start the loop right back over again, because that's not the condition we need for us to break out of the loop. Once we actually type in your name, now we break out of the loop and we continue on with the rest of the program, which is just this single line at the bottom. Now, I can continue out of here. The project works just fine. So if I type in Jason, it runs, but then it goes ahead and continues the loop back over. So why would we ever use a continue? Well, that may work for this particular one where I wanted to start the thing over again, but I may now have another elif condition where name is equal to Sally. I could do something different. And go through there. So if I want to check specifically for Jason, do something and then start this loop back over, I could. If I don't do this, well, then it's never going to give me any output specifically for Jason. So that's the reason we would use a continue up here as opposed to leaving it out, is when you have other conditions that are being checked. Notice that I don't have to have an else statement here. Else's are possible, but they're not required. Same way with elif statements, you can use them or you cannot use them. You could just have a simple if statement and that's it. The only thing required in a if, elif, and else block is an if statement itself. It's the only one that's required. Anybody got any questions on this? Okay. So we got breaks, we got continues. Now we're going to use the for loops. So when we did a while statement down here, when we were looking at this count, let me go ahead and just get rid of this part here. And let's go back and look at count. We had to define count first. Then we were going to go through. We were going to add one every time until count is greater than 5. Then we can go ahead and move on with our code. In a for loop, we're going to do it for a finite number of times. So we're not going to be checking for this condition of 5 and finding out whether we're greater than 5. We want to just loop through 5 times. That's it. So while true, you could use it for infinite amount of times. You could set a condition until it's met. But if we just want to loop through a certain number of times, we use a for loop and the range function. So how does this look like? We would say something like for I, we're just giving a variable letter here, I, in range of say 5, then we're going to print I. So if we execute this code, let me go ahead and comment out this while statement and run it. Notice that we get welcome to the program, then we hit our for loop. So the first time it's going to give I a 0. When we do this range command, the first instance here is what you're going to go up to if that's all you're giving it. So notice how we go up to 5, but do not include 5. We start at 0 and we work our way up. So 0, 1, 2, 3, 4. If I wanted to start at 1, then I say in range of 1 to 5. Again, that's not going to give me 0 anymore, and it's not going to give me 5 because I'm up to but not including. Again, what we're doing here is we're assigning this I variable to whatever number is coming out of this range. This range is actually building a list. We'll talk about those next week. And then we're just doing a loop through that particular list. But for what you guys need to know right now with the range command, it's a way to get a range of something to something. There is a third part to a range command, and this is going to be a step. So if I only want the evens, and I'm starting off at 2, so I'm going to start at the number 2. I'm going to go up to, let's try the number 10 here. Notice that doesn't include 10. So if I wanted to include 10, I would put 11. And I'm going to go by 2s. So if I print this, I get 2, 4, 6, 8, 10. If I want the odds, I would start at 1. I would not go, 11 still fine, go by 2s. Now I get 1, 2, 1, 3, 5, 6, 7, 9. Sorry, 1, 3, 5, 7, 9. So this is a way that you can use a step incrementer that you want to go through there. If you want to go by 5s, I'm only going to get 1 and 6 because I started at 1. If I want to start at 0, then I have to tell it 0. If I leave 0 off, what's that going to do? I adjusted my steps, right? So when you pass things into a function, the order in which you pass them in is important. You can omit some of those, and we'll talk more about this when we get into functions and writing functions. But for right now, all you need to know is that the first spot is going to be your start. It includes that number. The second one is up to, but not including. The third spot is the incrementer that you want to use. So if I want just my evens, or I start at 0, oops, I forgot my parenthesis. We now have 0, 5, and 10. Everybody understand the range command? Now I can set this I to whatever I want. Say I use number, and then I tell it to print that number. Then I can go ahead and do that as well. Nothing changes. It's common for people to use I, but you can use whatever you want. I recommend when you do variables, you give it something that's some sort of relevance, right? So we're defining number here. We're taking it a number for every time it goes through the loop. We can print it. We can adjust it. We could do whatever we want. It's a variable. We can do whatever we want at this point. Anybody got any questions on the range command? I will tell you it's on an upcoming quiz and some other stuff in there. So understand the range command as a whole. Notice that you can do the equivalent of a while loop by doing the same thing with the for loop, right? So in the first one, we had our count equals 0 while count is less than 5. Then we do that. We can do the same thing here by saying starting at 0, going up to 5, but not including 5. And we can print that number. And this would be the exact same thing. So if we uncomment, we're going to take this print statement, put it here. Only instead of count, we're now using number. It's going to loop back over. So the first time it went through the while loop, it did this. When it goes through the for loop, it did this. So you could use this either way. The key here is if you have a finite number that you know you want to go through, for loop is technically faster. It will execute those commands faster. While loop, it has to do some other stuff. All right, does everybody understand the arguments to the range command? Again, you do the starting, the stopping, and stepping. Those are the names of those 3 spots inside of a range function. Okay, let's see. How much more do I got here? We'll get through this range command or importing as well. So the next thing they're going to have in here is going to be importing modules. In Python, you have a bunch of built-in functions. Like we've talked about integer, we've talked about floating point and string where you do int or print. That's a built-in function into Python, and it's part of the standard library. So we don't have to import any of that. It's just built into Python. There's some math-related stuff that you can do, but it's all built into Python. So we need to import that into our project if we're going to use stuff outside of the normal standard. So the first one we're going to use is import random. So I'm going to comment out this stuff here. Go down to the bottom of our program here. Whoops. And now we're going to do import random. then we're going to use the random module. So we're going to say random number. You can call this whatever you want, equals, we're going to use random dot rand int. And this rand int function is going to create a random integer. But we need to feed it some variables that are going to come up here. So you'll see when I start to type this out, go back here a little bit. Notice how if I stop typing, it's going to pop up here an idle and have an A and a B. So I need to have two things in there. It's going to want a range, and it includes both endpoints. So unlike using the range command, if I put in 1,5, it's going to give me any number between 1 and 5, including 5. This is the difference between the range command, which goes up to but does not include. This one does. So if I want a random number between 1 and 5, then I tell it to print that random number. We run. In this case, we got 5. If I run it again, we got 5. Now we got 4. And every time we run this, we're going to get something different, or maybe the same. It's always random. So this is what you'll use as the random. This is called a module. The rand int is a function or method within that random module. Now, when you do imports, always do the import at the top. Do not do it in the middle of your code. It should be before your code ever starts. So notice I'm putting it up here before welcome to program. Always do your imports at the top, never in the middle of your code. I will start counting off on that on assignments after this first week. So when you guys are working on your projects and things like that, always do your import parts up at the top. And the reason for that is you don't want to get all the way through your code later on when you're importing third-party modules and things like that. You don't want to get middle of your code and then find out you don't have the module. So imports always go to the top. You can import several different things, and we'll work with different modules like the OS. We'll work with system. We'll work with a couple of different ones. But import random at the top is the main one. So random, if you're going to use random numbers. If I'm not going to use a random number, then I don't need to use the random module. Don't import it. Everything you import is going to cause you to have, it's going to use more space, more RAM, more memory within your project, which is irrelevant when we're working on computers these days. It doesn't matter. But when we are working on like small embedded controllers and programming in Python and things like that, we want to keep it as clean and concise as possible. All right. At the bottom of these different sections, you're going to have a bunch of these different projects down here at the bottom. If you're struggling to do some imports, or I'm sorry, if you're struggling to do functions and things like this, test yourself with these different projects. It's going to say, here's how I do it. You know, like in this one, it's a guess the number game, which is usually the most common thing for assignment 1. People do something like guess the random number, and then you can do a bunch of different manipulations with that. But I encourage you to do these short programs and make sure that you're familiar with what you're doing in these particular sections. There's always those, there's these practice questions. You can ask yourself these if you want. They have the answer keys that you can go look up. You can Google search any of these projects and you can probably find answer keys there as well. Another module that we'll import is import sys. This is the system module. We'll primarily do this at the end. We just say, thank you for using my program, and the program just ends. To do this better, we would use sys.exit, and that would end our project cleanly as it would end as a whole. So if I run this, now I run my project, it does the same thing, it still ends. But later on, when we start doing certain things and we want to end this project, maybe somewhere up here in the middle, we would use sys.exit to end our program at that point in time. It wouldn't continue on executing code. So those are the two for this week, import random and import sys. And the main ones that you would use from sys is exit. Another way to do imports is going to be just bringing in the one module. So right now, when I import random, there's a lot of things I can do with random. So if I start with random and hit dot, oops, it started to come up and I misclicked. It's going to tell me all the different modules that are a part of random. So we learned random int, which gives us a random integer. We could do random choice, which is a common one people may use. So say I have a list of different choices and I want to get a random choice out of there, I could bring that back. We'll talk about that more when we deal with lists, so you guys know what that part means. If I just want random int out of there and I don't want all the other ones imported into my project, I could use from random import randint. And now I'm just bringing that one module into my project, not everything. Again, this is important when you're using with larger programs. You want to keep them as small as possible. If I don't want to import everything from random, I just need one little thing. This is how you do it with from. You can also say from random import star, which will import everything in, just like you did with random. Only now, instead of me having to say random.int, I can just say randint. That function becomes a part of my normal project. I no longer have to specify what module it comes from. This will be important when you get to your midterm and your final project, when you start working with multiple files and things like that. All right, anybody have any questions on this? Start working on the homework assignment. We'll go over a little bit of that on Thursday. And then I also have a demonstration that kind of explains a little bit more on for loops and while loops and things like that. It's more of a visual way of doing it. All right, we'll see you on Thursday.